Hi everyone, welcome to Math Spellbook. I'm your host Peter, and basically we are going to get back into basically doing some math and physics today. And also thank you very much to all of you that have dropped a follow, because I just realized that we hit 100 today, or maybe we hit 100 like I think it said like 2 days ago. So I'm like, thank you guys for actually dropping a follow, and hopefully the content continues to intrigue you guys to continue learning more about math, physics, or whatever it is you're learning currently. So let's see here. So I think we were somewhere around here. Or was it number 4? Oh no, number 4 I think we did last time. So I think we were on 5, so let's just copy this. How you guys doing today? It is Monday. It's almost July. Only one day away until July, so hopefully you guys are enjoying yourselves. Okay. Let's just drag this over here. Okay, so we have question. So A. So at least we got the definition. So let's see. Given an ordered field of F, we'll probably be jumping around a bit, because I still have to cover things like Cauchy sequences, and I haven't gone over those yet, or like reviewed those yet, since Sasha taught me those. So let's see. Given an ordered field F, recall that we defined the positive elements to be a non-empty set. P is a subset of F that satisfies both the following conditions. If A and B are in P, then A plus B is in P, and A times B is in P. If A is in F and A is not equal to 0, then either A is in P or negative A is in P, but not both. Okay, so for A we have to, let's see, we have give an example of sum of P1 is a subset of the reals that satisfies 1 but not 2. Okay. So we have to remember for I, it's if A and B is in P, then B plus P is in P, and A times B is in P. But we have to do it without triggering number, or the second one. So P is a subset of the field. A and B are elements of P, which means they're the positives. And we have to give some examples of P1. So P1 has to be a subset of P, which is a subset of F. Thanks, Sascha. How's it going? What's the best part of your day so far, my friend? So the thing of it is that this question, I don't know if it just wants us to give like an actual proof, or does it want us to actually give an example? Like just basically just write down like something that actually fits it. Like a greater than or less than symbol. Yeah, because I'm guessing P1 is supposed to be a subset of P, which is a subset of F. So... maybe it is a proof-based question. An A and B, and P1. And P1. Maybe we should erase this because it says it's a subset of the real numbers, so that satisfies. Okay. So if we were to think this very deeply, A and B could be like any numbers, any of the numbers. I mean, do we have to do this by a case-by-case basis? No, I don't think so. Because I was thinking about the case-by-case, like what if A is like even and B is odd and vice versa. But I don't think we need to do that. Because we just have to show that it's like the first one, but not the second one. You just need to think of an example. Oh, okay. So the second one basically says that if A is an F and A is not equal to 0, then either A is in P or negative A is in P, but not both. So we have to make sure we don't trigger the second one. So now we have to think of a good example here. Let's see. I mean, with like, if we think of the numbers like natural numbers, then it would make sense because P is in the real numbers. However, we have to make it so that it's not both A and negative A at the same time. example. What is a good example of the first one without triggering the second one? Because the only thing I can think of is like it would be both, like if it would would a number squared work? Let's see, if you add a square and add a square. For some reason I keep thinking of the Pythagorean theorem. Like when I see a plus b, and if it's like a is equal to like x squared and like b is equal to y squared, then basically it would be the Pythagorean theorem. But when I think of the squares, like basically like it's both at the same time, because you can have like negative numbers with square them, and then you can square like negative numbers, and then they will come positive, which is it kind of does go against the second one, because it's kind of, I mean, it can be both, but at the same time I don't know if that's what they're getting at. Maybe I'm a bit off with that explanation. So if it's just an example, I think we'll just like write ideas just so that we can have something to write. So like let's say a is x squared and b is y squared. let's just keep that in mind. It might be off, but I feel as if that could be something we could probably use, maybe. Or maybe I'm just off and like because this is really kind of thinking rigorously here, like how the system can break, and I'm trying to think about how the system can break in this point. Like we want to break the second one, like this one, but we want to maintain this one. Because if it's x squared times y squared, then you just end up with another number that's squared. But you can also include the negative versions of those numbers, because since they're squared, they're always going to turn positive at that point. But that's the only thing I can think of at this point. I don't know if that is the correct way to view this particular problem. And I think if once we understand how to answer A, then we can probably understand a little bit better with B. Let's see. I just want to write B so that we can have a little bit done here. This idea would be more suitable for B. Why is that? Why would it be only suitable for B and not A in this case? Oh, you mean the problem A and B, right? Is that what you meant? Squaring is not stable under addition, yeah. Like, what do you mean by that exactly, Sascha? Let's see. feels like when you do the first one, it seems like all the numbers fit into this parameter because it's supposed to be all the real numbers. Yeah, it's the real numbers. Yeah, it's not just the integers, it's the real numbers. Because it seems like all the numbers fit in this particular... But the thing of it is that, like, I'm trying to make sure that it doesn't fit into the second criteria, which is the field criteria, where it's like, if A is an element of F and A isn't not equal to 0, then either A is in P or negative A is in P, but not both. Then squaring will just get you the positive real numbers, as any positive real number is the square of some other real number. Yeah, that's why I think that, but then again, yeah, because, like, it gives you, yeah, because I think my thinking was a bit flawed there. Because when I think about it, it only gives you the positive version of it. But it says or, so I think the square root can better fit that criteria, so it probably doesn't work. Yeah, you are right. Because it's kind of like an or statement when you think about the square root. I mean, not the square root, squaring a number. Because it can be either positive or negative, but it's not both at the same time. And when I think about both of them being both, but they have to be in P at the same time. And the real numbers, they do contain all the negative numbers. So... Because the thing of it is that if you multiply a positive and a negative, then you end up with a negative. And it's not really both. I must be missing something. But what am I missing? Because squaring a number fulfills it. Because I can't think of a number that would probably give you both negative and positive at the same time. Unless I'm thinking of this problem incorrectly. So we could find a strict subset of positive real numbers which satisfies 1. Well, I'm guessing that's P1 because we have because it's supposed to be that P1 is a subset of the real numbers. So probably we have to define what P1 is. I think I know what you meant by that, yeah. It's like the property of I instead of double I. Don't worry, I understood, Sascha. So can you reformulate double I for me, as if I was a layman. So according to the way it says it says that if A is an element of the field that we're working with, or the ordered field, and A is not equal to 0, then either A is in P or negative A is in P, but not both. Maybe rereading it. Maybe I was like misreading it to myself, because now that I read it out loud, it kind of feels like I was kind of missing something. Because it said but not both, and the thing of it is that, like, when would both of them be in there? But then at the same time, it's like we're working with a subset of the real numbers. Would P equal R satisfy that? P2 would... Let's see, give an example of some P2 where that satisfies 2 but not 1. So yeah, the first one we can probably say that P1 is equal to the real numbers, because then yeah, you have to have both in the set in that case. That would kind of make sense. I think it satisfies I, like for P1 to equal R, because both of them would have to be in the set in this case, A and negative A. So number 2 doesn't hold in this case, because both of them are in this particular set. Because it is the real numbers, and the real numbers has to contain both of these. So now we have to think about for P2. So for B, give an example of P2 where 2 is a subset of R that satisfies I2 but not I1. So that means we can't do the regular arithmetic, which means we can't have it like this. Okay, so it has to satisfy. So it has to have. So it has to have them separately. So basically, we have to have positive numbers and negative numbers, and it does not satisfy. Oh wait, hold on. If it's a subset of the real numbers, then wait. I think I have an idea. But what would happen if P2, oops, not R, if P2 was equal to no, not that one. I have an idea, but it's like conflicting with other thoughts in my head. I feel like I'm on it though. somewhere. Now, is that correct though? Because let's see. Because it satisfies 2. And I think it won't satisfy 1 because there's always going to be something missing within, because since it is a subset of the real numbers, but since it is the rational numbers, it's going to be missing some things, which you cannot do in addition and multiplication, such as, like, you know, the square root numbers. But I'm trying to think it all the way through, because I'm trying to make sure that that is the correct way of thinking about it. Yeah. Oh, yeah. Because it has both the negative numbers. Yeah, that doesn't work. Yeah, and the natural numbers, it fulfills 1, so that doesn't work either. So that means we're gonna have to make a complicated set. Well, not complicated, it's just we have to think about something deeper. Because it can't contain both the negative and the positive numbers. So that means it has to be either positive or negative. Which means we can probably use I mean, we can, because if we use, like, say, like let's say a is equal to x squared, for example, and such that x is an element of say the real numbers. But the thing of it is that that would still fulfill I in this case, or 1. We'll call them 1 and 2 because it's, like, you know, it's just a bunch of i's. So it has to be a certain condition. So I think 2 is a set such that. I don't think that might be right. It's like we gotta have some sort of condition here. Because we have to have the set not have the negative and the positives at the same time. In addition, we have to make sure that the numbers don't multiply or add together to form a number that's in that particular set. And like the only numbers that I see that kind of split off of the subsets of each other is the rationals to the real numbers and the integers to the rational numbers. I feel like we're on close to the right track. It's just that formulating it is because so let's think about the procedure to build a subset that satisfies 2. Yeah, that's what I'm thinking about doing. That's quite right. I mean, if you had x as a half, then basically you would have the square root of 2 on the bottom of the denominator. So if you had like a plus b, and then if you had like a times b, you would end up with a irrational number in that case. So basically to force us to make a choice between choosing to put x or negative x in our P2 set for any non-zero real number. Yeah, that's basically what it's asking. You have to fulfill 2, but you can't fulfill 1. And I know for like if you want to eliminate 1, you have to basically give a number in the set that basically is not within the subset that you've chosen. Yeah, I kind of figured as much. Yeah, because when I think it through, it's kind of like a bit convoluted. I don't know if I'm making this more difficult than it needs to be. Because I know it has something to do with basically getting the numbers to be outside of the set that they're being... so we have to have P2 equal to one of the subsets. Or something like in between. Because we can't have it being the real numbers, because the real numbers have everything that we need and it's complete. The integers, the problem with them is that they both have negative and positive numbers in it, so we can't have it equal to that. The problem with the natural numbers is that you can do arithmetic with them very easily, and you will get a number within the set, and that's the thing that's like, that's the thing that's kind of like elusive right there. So what is the most basic example that satisfies 2? Yeah, I'm trying to think about that. Because I know the natural numbers don't work because they fulfill 1. The integers, they have both the negative and positive numbers. Yeah. The rational numbers, they don't work because they have both in them. And the real numbers, they have both in every single number that completes it. Because the only thing that makes the natural numbers would work for 2. The problem is that it also works for 1, and that's the thing that really is like preventing us. So I think we're gonna have to do some sort of condition. Because it has to be a number that's not in the set itself. That's what we have to do, eliminate for 1, so. No, the natural numbers don't satisfy 2. Why not? Because it is in the field, and it has to be either positive A or negative A, but not both of them. Like, why doesn't it not satisfy that? Unless I'm not thinking about this correctly. Because usually when I think of the sets, I think of it like if we have like the regular integers, I think that we can't use it because it has both -1 and +1. That's how I think of it, but maybe I'm thinking of it incorrectly. Well, the square root of 2 is not a natural number, so it fails for. Well, the square root of 2, I know it's not a natural number, but if I had like p2 equal to the natural numbers, because what my thought was is that if we did it like this, like basically p2 is equal to the natural numbers, the problem with it is that it also fulfills 1, because every natural number you add together or multiply together will give you a natural number, and that's the thing that kind of takes away from it. That's why I feel like that this doesn't work. That's what my my way of thinking of it is. Yeah, but to ask us to take a in the real number. Let me see. It says give some example, and that p2 is a subset of the real numbers. So I think if it's a subset of the real numbers, then that means it could be any of the subsets within the real numbers. That's what I got from that. Yeah, but to ask us to take a in the real numbers. Am I reading the question wrong? Because it doesn't say to assume that. It just says that p2 is a subset of the real numbers. And what I take from that is that we can use any of the smaller subsets within that as we want. That's why, like, you know, like, the natural numbers don't work because it works for 2, but it also works for 1, and that's the thing we don't want. For the rational numbers, it includes both the negative and the real and the positive numbers. So that doesn't work because it doesn't fulfill 2 in that case. Now, for obviously the real numbers, we can't use them because it fulfills all conditions. Both conditions at the same time. So the natural numbers and the real numbers fulfill those conditions at the same time. The integers and the rational numbers don't work because they include both the negative and the positive numbers. Yeah, but the condition, but read, 2 reads as follows: when when f is equal to r, if a is a non-zero number, it just basically says that a is in f. I don't see where it says f is equal to the real numbers. The only thing that I see that has the real numbers is the p2 is a subset of the real numbers. Am I misreading things? The question should say that f is equal to r. F has to be a field. Yeah, it basically says that f is an ordered field. Do I have to get the definition of what a field is? Or an ordered field? This is gonna take a minute. I can't jump to other stuff. Let's see, definition, that's boundedness. That's the triangle inequality. Gotta go all the way back. Here we go. If f is an ordered field like the real numbers, defined by absolute value, that's absolute value. If f is an ordered field, A and B is just okay. An ordered field, here we go. A non-empty set, yeah, that's exactly what we got here. Because it says like the real numbers, but it doesn't define that as the real numbers. Unless you're supposed to take that for granted. Just take F to be real numbers. Okay. I mean, that's fair, because we are dealing with the real numbers, so that probably makes sense. Yeah, here. Okay, yeah, this makes it harder. Because if we made P1 equal to the real numbers, then yeah, it actually doesn't fulfill 2 in this case, because it has both the negative and the positive numbers. Now for the second one, we want number 2. We want number 2, but we don't want number 1, which makes it a little bit harder. Because if we make P2 the natural numbers, it still does arithmetic well, so it fulfills 1. That's the problem. And the real numbers do the exact same thing. But the real numbers fulfill both 1 and 2. So the real numbers fulfill 1 and 2. The rationals and the integers, they fulfill 2. They don't fulfill 2 actually, because there's both in them. So no. I'm mixing up. So the real numbers, they don't fulfill 2 because they have both negative and positive numbers in them. I don't think so. I don't think I see why it isn't. It doesn't work for 2. Because in my mind, since the natural numbers don't have negative numbers, I still think that it fulfills like A is in P, but negative A does not. And that's why I think it kind of does fulfill number 2, but I'm not thinking of that right. That's why I'm like sort of getting flustered, because I'm trying to see what you're seeing, but at the same time I'm like, why is it that I am not seeing it? Because when I think of it, like what I know about the natural numbers is that it doesn't have negative numbers. And what number 2 says is that if A is in F and A is not 0, then either A is in P or negative A is in P, but not both. And when I think of the natural numbers, I just think of positive numbers. But A would equal the square root of 2, so... Okay, so we're treating it as if A is in the real numbers in this case. Because I think is what's confusing me is because it says that A is in the field, and we have to remember that F has properties, and F is supposed to be like the real numbers in this case. I think that's the reason why I'm getting a little bit confused. Because I'm so used to thinking of like, because if the natural numbers don't work, because what I'm thinking is that P is supposed to be because P is supposed to be a subset of the field, right? And the thing of it is that, because it says P, it doesn't say F. So when I think of it, it's like P2, if it was equal to the natural numbers, it's a subset of R, which is aka F. But it has to be a subset, it has to be an element of the subset, which is P2. And P2 is supposed to be the natural numbers. So now I'm getting I think the reason why I'm getting confused is because, are we supposed to be thinking about F, or are we supposed to be thinking about P? Because what we have here is that it's supposed to be an element of P. And if I have like P2 in this case, and we'll replace that with P, what I'm thinking is that if it is equal to the natural numbers, then this fulfillment, I think this fulfillment is fulfilled. But it's also an element of like F, aka the real numbers. So I think that's where I'm getting confused about, because it's like, so is it supposed to be part of F or is it supposed to be part of P? That's the one thing that I'm getting really confused about. Yeah, taking the real numbers to be the natural numbers. Yeah, our field here is the real numbers here. Yeah, but the condition starts by saying if A is in the real numbers, right? You're reading the implication the wrong way. A is in the real numbers. Okay, so it's in the real numbers, so that means it has to be a real number when it's in P. Is that what it is? So is A supposed to have the properties of P, or is it supposed to have the properties of F? That's the one thing that I think maybe I'm getting confused about. Because the way I'm thinking about it, the way you're explaining it, Sasha, is that I think it's like what you're trying to tell me is that since A is an element of F, or aka the real numbers, then I'm thinking that it takes the properties of that and then puts it into P in this case, or P2 if we want to be specific. The properties of the reals. And it's somehow in this one. That's what I'm thinking you're trying to convey to me. Unless I'm thinking of it wrong. So any non-zero real number A, your set P must either have, yes, A or negative A. Yeah, that part I understand. The one thing is that, am I just getting the way the property of A is supposed to be placed here? Because I think what you're trying to explain to me is that A has the properties of this set, but it somehow takes it to this set. That's what I'm thinking that you're trying to explain to me. But I also want to make sure that I'm not thinking wrong in this case. I don't know if that's the right word. Wrongly. I probably made that up. Or incorrectly, I should say. Incorrectly. Hey Don, how's it going? I'll give you a shout out, Don. If you guys are not familiar with Don Factorial, Don is another math streamer, along with he plays video games, so be sure to check out his content. Don Factorial. I'm gonna make sure that I spelled that correctly. So do you agree that the square root of 2 is a real number? Yes. Yes. And I know that if you have the real, if A is in the real numbers, then that means, yeah, we would also have to include negative square root of 2. Yeah, I'm just basically struggling on this one question. And it's not even a proof question, it's just an example question. Because I think what you're telling me, Sasha, is that since the first part is that if A is an F, aka the real numbers, or field like the real numbers, that A is supposed to encompass all the properties of the real numbers, and it carries over to like the subset of P. And I'm thinking that's the reason why you're telling me that the natural numbers do not work for this example. Because that's how my thought process is going, but I don't know if that's the correct way of viewing it. But how you doing, Don? How you doing? Don has also been working on some physics problems. I have to actually get on that. I've been working on a lot of more math than physics, actually. Doing well, just debating what I want from this one from Steam, the summer sale. Hope your day is going well. It's going all right. I can't complain. Hopefully, like, I'm making progress with these proof questions, because I feel like I'm just like stumbling too much. So if p is equal to the natural numbers, it would satisfy 2, then you have to tell me if p contains the square root of 2 or the negative square root. Okay, so yeah, so and that's where I'm getting confused, because like I know the square root of 2 is not a natural number. And the thing of it is that that's why I asked, is like, because in number 2 it says like if a is an element of f, or aka the real numbers, that's the reason why I asked, does it take the property of the real numbers and puts it into the subset, which is p2? Because for you to ask that question, it makes sense to me that basically we have to think about it as if a takes on the property of the real numbers, like basically all the numbers within the real numbers, and then transplant that property into p2. Which makes more sense, because if p2 was the natural numbers, let's just say hypothetically, then like it would make sense to me in my brain that basically like all the numbers in p2 are all natural numbers. In other words, like they don't contain any negative numbers or any rational numbers or any real numbers in it. But since you're asking me that question about whether the square root of 2 or the negative square root of 2 is contained in p, that makes me think that we have to think about this first. It's as if we kind of took the... It's as if we took the real number property and just put it in this one, even though this is still considered the natural numbers. I'm trying to get the thinking structure right. That's the reason why I keep repeating myself over and over again with it. Your hypothesis that a is real, and the conclusion is that either a or negative a is in p. But it cannot be both. That's the thing, because it's not that inclusive or. Could you show the top part of the question? Yeah, sure. It just basically says that, so Don, what we're working with is that given an ordered field of F, recall that we defined that the positive elements to be a non-empty subset, P subset of the field that satisfies both the following conditions. And the question we're dealing with is question B, where is that we have to fulfill 2, but we cannot fulfill 1. And I think I've been stuck on it because, like, I keep thinking that if we chose because right here for letter A, I understood it by basically thinking, oh, like since the real numbers have both the negative and the positive numbers in it, then it cannot fulfill 2. And that's one example I thought of for P1. For letter A, for P1. Now for letter B, for P2, we have to satisfy 2, but not 1. Now, I know the natural numbers, like when I thought of it, like the way I thought of this one, is that I thought that if we turn P2 to the natural numbers, that basically we can fulfill this because it only has like the positive numbers, but then I didn't realize that we also have this part. So now I'm basically trying to think about like, okay, so what does this property mean? And I think that's the reason why I keep getting confused. Because according to Sasha, it seems like the way he described it, like over and over again with me, is that it seems as if A, the element we're dealing with, has to have the properties of the real numbers first before it actually is within the subset P2. And the thing of it is that if we do have the real numbers here, then the square root of 2 has to be in this set here. So that means the natural numbers can't work because the square root of 2 is not a natural number. So it's always going to be the real numbers for this case. So that means we can't make P2 a certain set then. So what's a good counterexample to this? Because we can't have P2 equal a set, because either way A is going to be a real number. So if A is going to be a real number, then does that mean we have to change A in this case? Like P2 is so does that mean we have to actually change the property of A to be like some sort of other number? But we can't because it's in the field. Okay, let's think about an example that satisfies 1 and 2. Okay, well, if 2 just turns everything into a real number, right? Because actually, let's see. So the way I solved interesting. I think I have an idea, but I'll let you keep working on it. Okay. So why is letter A right? I have to think about why is that right. To me, the reason why I think it's right is basically you actually do all the arithmetic and it all fits within the set of the real numbers. But if you have like 2 here, like since it is the set of the real numbers and A is in the real numbers, but the problem is that the real numbers also contain the negative and the positive numbers in it, which is why it doesn't fulfill that. So now we have to think about what fulfills 2 here. So what fulfills both sets? So if I was thinking about, let's say, because like I'm going back to A a lot because we got A correct. So I'm trying to think about why is it that the real numbers work for 1 but not work for 2, and now I have to think about what works for both 1 and 2 in this case. So that's why I keep going back to going back to A in this case. What is the name of the set that satisfies 1 and 2? Yeah, that's what I'm thinking about now. That's why I keep going back to like A, because we got that right. Because it cannot be both, because it says not both. It's either A or negative A. Okay, no problem, Sasha. Take your time. Okay, so what fulfills both conditions if they're ordered fields? Well, if we think of ordered fields, I think the rational numbers are supposed to work because I remember reading that in the book, but I'm like, now I gotta think about why does that work? Because if A and B are rational numbers, then the arithmetic, I mean, do we have square roots in rational numbers? We have some of them, but not all of them. Hey, welcome back. So I have to think about what's an ordered field. I think the rational numbers are also or an ordered field. They just aren't complete. Or are they? No, I think they're not complete because there's still gaps. But I think it's supposed to be an ordered field. Steam summer sale. Oh no. Hey Venvox fan. What's the best part of your day so far? Okay, what is condition 1 and 2 trying to generalize? Well, it seems like 1 is trying to generalize the operations that could take place. So in other words, it has to be closed. So that it looks like all the elements of the particular set have to be in the set, like the sum and the multiplication process. Now for 2, it seems as if it's like telling you that it cannot be both a negative and a positive number at the same time. Working out on Learn series. That is pretty great. Oh, okay. That sounds like fun. Okay, what is the little text at the top above saying? Are you talking about at the beginning of the question? Like F is a ordered field? Let's see. Given that an ordered field F, recall that we defined that the positive elements to be a non-empty subset P, which is a subset of F, which could be a set of the real numbers that satisfies both the following conditions. Okay, so it has to have both in order to be an ordered field. Now, what I remember from the book is that I believe that the rational numbers are supposed to be an ordered field. Now, if the rational numbers... So what is the thing we are trying to generalize? It seems as though we're trying to generalize the set itself. Because if it is a field, then basically it has to have, like, it's supposed to be like not an operation, but a set of rules that has to be abide by within a set in order for it to actually be it's like a set of, I think it's like basically a bunch of rules that a set has to possess in order to be, I guess, quote unquote, an ordered field. Like, that's the best way I can, like, generalize it in my head. Because I think that's what a field is. It's basically just a set of rules that allows the set to be more versatile and symmetric. Or it makes more sense. Or gives patterns that make coherent sense. That's the way I can think of it. Yeah, we're working out like part B right now. Fanbox fan. No problem. Take your time. You are correct that Q and R are ordered sets, or ordered fields. But what set? But here the condition 1 and 2 are not the condition that make F an ordered field. So is it that I have to think about the whole entire list that makes a field? Like, you know, like the commutative property, the distributive property, and the associative property. Oh, okay, no? Okay. Because practically we're trying to make it so, because it seems as though so P has to be a subset of the field, right? So if P is a subset of the field, then that means it has like the elements. What is the name of that author? Is given to P, gives to P. I'm not sure what you mean by that. Like, are you asking about like who's the author of the book? Oh, what is the name of P in this case? Well, according to the way the question is stated, it says it's the positive elements, but in the book, hello, disinefficient. Because I think they define P as just the positive numbers. P is the primordial ideal. But what's the best part of your day so far? Disinefficient. We got ordered fields here. Non-empty set. It's supposed to be the positive elements. It looks like you finished that last problem. Oh, thank you. Appreciate that. Appreciate that, disinefficients. So condition 1 and condition 2 are about generalizing the notion of positive real numbers. Okay. That's what I'm thinking you meant, like the positive elements, but I wasn't sure if it was a bigger idea than that. It's okay. I forgive pronunciation, American fellow. Thanks, I appreciate that. Is it okay if I call you Des just to shorten your name? Because like I think the reason why I read it funny was because I have to look at every syllable just to make sure that I'm pronouncing it correctly. Always appreciate you in the chat. That's an abstraction of the notion of real numbers. So when f is equal to r and take p to be the positive real numbers, it should satisfy a and 1 and 2 real positive real numbers. Okay, no problem. Yeah, I know you're trying to explain it and like I'm not getting it. Hopefully my slowness doesn't agitate you, Sascha. Let's see. when F and R, because I think I get flustered with myself and I'm trying not to like lose it. Take P to be a positive real number would satisfy. Fraction of positive real numbers. Sorry if you guys hear me chewing. I'm basically chewing on a cough drop. I had a history Harvard. Oh, wow. I think he was kicked out of academia because he was teaching at a community college. He said that you can call me whatever you want. Whatever you want, but but you will respect my rules. Funny. That's funny. But that's weird. Like, he got kicked out for teaching at a community college? Jeez. Like, he was like, I'm not getting paid enough at this institution. I need to make more money. You know when with entrepreneurs they say, like, in order to be in business, hold on. I don't like the way my chat looks. Oh, I thought like I thought something was missing in chat, but I guess not. I guess that was just my own eyes tricking me. Okay, so the natural so making P2 equal to natural numbers does not work. So basically what we have to, so what I was thinking is what you explained, Sasha, is basically like A, it has to start out that A is part of the real numbers because it's in the field first. And then when it gets to P, it actually is incorporated in P. So in other words, the property of the real numbers has to be in A. And then that has to carry over to when it's in P. I mean, that's the way I can best describe it in my head. So the question is that how can we make this work? Because it has to have, because since it is part of the real numbers, then we're going to have the negative and the positive numbers in it. And that's going to be a little bit of an issue to work out with. Unless we have to set up P where it eliminates the negative numbers. Like, you know, set A to be the square root of, set A to be the square, set P2 to be equal to the square of A, in this case. What's the difference of I and closure over a ring? That's a good question. I don't know. Because I still haven't reviewed rings yet. Because I remember Sasha went over rings with me when he was teaching me. Well, P as either to choose between A or negative A. Exclusive. Yeah, exclusive or, yeah. Yeah, the only thing I can think of is that we set P2 to be like have an operation, like sort of like I don't know if function is the right word, because like if P2 is supposed to be a subset of the real numbers, then it can also take on properties like you know, making the square of something. So if we set P2 to be a set such that A is the real number, so my idea is that so obviously A has to remain a real number, so A is an element of the real numbers such that A squared is an element of P2. Actually, I should erase this mind map I had. It's not really necessary in here. Because that way, if we have any negative numbers, they will be eliminated by the square. Now the thing is that I mean, it can work, because if we do have the square root of, if we have the square root of 2, or negative square root of 2, that is a, and basically if it's like f, I mean, if it's like in 1, or I, then if a is equal to, because then it would be in, but it would still be part of the, real numbers though, so that might not work. But do you want the, but do you want positive numbers for B? That is also a good question, because it only talks about A. But do you want B to have positive numbers? I didn't think about that actually, because it says A, but that can also be the same for B, right? Because B is also part of the field. But why does it just say A though? Does that mean it only has to affect one of the variables? Wow. It's like we're like almost a half an hour to ending stream, and yet we're basically on these two parts of one question. Hopefully you guys learn a lot from my struggle. Because originally I was just planning to like do like this problem and then like try to do some multivariable calculus problems. But this one is like very, very deep. It's actually making me think a lot deeper about like what makes, I guess, like this idea more, more elaborate. I mean, I'm liking it, but at the same time, I'm like, wow. Now I understand a bit about why certain people go a little bit insane when like they're focused on one single thing. It's like there's like a big rabbit hole. There's a big rabbit hole to like just one definition. Or like one, I guess, like idea from like mathematics. Probably there should be a big sign like when someone says that, it's like, welcome to mathematics, where you get into a rabbit hole that never ends. Which is probably why Alice in Wonderland was written by a mathematician, maybe. This is not even the beginning, yeah. I know I'm slow. I am so slow. I haven't gone, I have to like review what Cauchy sequences are. And how to like actually do those. There's like in chapter 2 of this book, they go over cardinality. I don't know if I have to go over that. I mean, it's interesting to read about counting, because they do go over counting in that one, which I think is really cool. And like, I think chapter 3 is supposed to be about sequences. If P2 contains only positive real numbers satisfy 2, there is only 2 possible choices for P2, and they both satisfy 1. So I'm guessing this idea is not great. Oops, I had to erase that. So there are no possible counterexamples if 2 contains only positive real numbers. No, we really need negative numbers. So be funny if you just write like, sorry, I didn't mean to write no. Oh, okay. We really need the negative numbers. Okay. Can we do acyl groups? Unfortunately, I don't know what that is. Now we really need the negative numbers. For some reason, I instantly thought, like, what if we just write the, what is it, the absolute value? P is like the set of all absolute value numbers. But were you doing group theory? No. So, the way that Sasha was teaching me is that he was incorporating a little bit of group theory, a little bit of rings, a little bit of stuff, just to explain where the negative numbers come from, how we get subtraction, how we get the rational numbers, and how we get the how we lead up to actually getting close to the real numbers. He was just basically adding like rings and groups to make it a little bit more elaborate, and I think more, I guess, mathematically versatile. So it's like, oh, like I'm interested in a little bit of groups, I'm interested in a little bit of rings, like, you know, just put a little bit of the, I guess, like stuff you wouldn't learn like in real analysis just yet, and just sprinkle it in there just to attune to my curiosity. It's a new way of learning, and I was like, ooh, I actually get to learn rings and groups a little bit early, instead of just taking them all into, like, say, like a abstract algebra course. I have reviewed the, I have to review then for my PhD entry exam. Oh, sounds tense. They really like to throw those in entry exams. I mean, that's pretty cool though, because like I actually like to learn like the stuff without having to, without having feeling like I have to be like taking a course just to learn it. Because I actually bought a book called Abstract Algebra, Student-Friendly Approach. It's by, I think it's by like a married couple, because they have the same last name, Laura L. Dozrez and Anthony J. Dorez. So like I've read that book. I mean, I've read a little bit of it, and like they explain everything so clearly. That's good. I wish I had that, except before learning analysis. Yeah, because like for me, I want to learn why is it that, let's say, why is it that you multiply two negative numbers together, you get a positive number, or why is it that, like, you know, subtraction exists even though it's not fully closed. You know, it's like stuff like that, and I think that's stuff like most students want to learn. The best book is by Robert Ashe. That's the best book. Ashe is my go. Right. What's the title of the book? I'll probably look it up and try to see if I can find it on Annie Archives. All right. So. Okay. Let's see. So we know that A is going to be an element of the real numbers and take on their properties, and A is not equal to 0. And A cannot be both positive and negative, so not both. So the thing of it is that if A is in the real numbers, then basically we have both A and negative A in the real numbers, but we have to make it so that they're not in P2. What are we we got here? Okay, I think I'll save this on my favorites here. 209. Oh, and it even has... Cool. I'm guessing you have to know real analysis to read this, right? The way he presents the book is awesome. No BS, direct to the point, and super concise. Cool. I will definitely add this. I'm guessing you have to know real analysis before you can read this book. So, that's another one for the library. Nope, just set theory and basic stuff. Oh, really? Interesting. Maybe I'll take a look at it. Because I do try to, like, read all the proof-based stuff, like, outside of stream. Just so that I can compile the ideas. Like, I'm even rewatching some of the old streams that I did with Sasha, so I can better solidify and write a good mind map of, like, what is it that I need to know. Obviously, I haven't mastered, like, the proof stuff, but at the same time, it's like getting the knowledge enough is, like, kind of like allowing my brain to, like, massage it a little bit. I don't like analysis. I was going to be a high school teacher. Then I looked, I took abstract algebra and decided for a grad. Algebra saved my life. That's good to know. That's good to know. Okay, so we know that these conditions have to be upheld. Now the question is that what can we make P so that it can take in the real numbers but only give us one of these, so that it fulfills 2. And also, hopefully, once we've fulfilled that condition, then we can find 1, or at least like make sure that 1 is not discoverable in this particular set in this case. So we gotta have to make 2 a certain set where it only gives us 1 of the numbers, like whether positive or negative in this case. So we're gonna write set notation. So P2 has to have some sort of operation that gives us 1 of them. So should we make it square root? Should we make it square root? Square root of A is a property of 2 such that A is an element of the real numbers. Now, if you're able to make correct conclusions from your understanding, then you know you can do proofs. Even better if these conclusions are known lemmas and theorems. Cool. What is your subject of interest in algebra? I probably don't get the joke, but that's maybe like the more I learn with you guys, maybe I will get it one day. I guess we have the same philosophy. I hope you guys can bond over that then. Okay, so the square root of A is in the real numbers. The thing of it is that we're not going to get the negative square root of A. I mean, if A is the negative version of a number, it's not going to be in the real numbers in this case. Information is perishable. We are all dumb anyways. Well, I'm glad I'm not alone in that case. I mean, it's like true when you learn math and physics. The more you learn, the stupider you feel. And yeah, like it makes you feel like you don't know a lot. But I think that's why people don't like learning the subjects, because it feels as if like the more you learn, you feel as if you're behind every single person that gets it. But it's okay. We're all in good company. We're all trying to like learn this stuff And if you really enjoy math and physics, like, you know, I'm glad that you guys like happen to find my channel. And if you're watching this for the first time, you know, drop a follow if you're watching it on Twitch. But if you're watching this on YouTube, you know, drop a like, comment, and subscribe. Because I always like making these videos for you guys. Now I don't know if I'm correct here, because let's see, if P2, if the square root of A is an element of P2, right? So we just take the property, we just made the property that it's the square root of A, and A is a real number. The problem is that for number 1, it has to take just A. So maybe that doesn't work. Well, wait a minute, so... Yeah, but... I don't know if I'm getting close. It feels like I'm sort of there, but at the same time, it feels like I'm just lacking something. Because A has to be a real number. And if we make the square root of A an element of P2, then technically A might not be in P, but maybe I'm thinking wrong. Well, P2 would be a real positive number, so this is not the way I should write the set then. Because I get a feeling we're supposed to alter P2 to a point where it actually gives us one or the other. So basically either a negative number or a positive number, but not both. No, it satisfies 1 and 2. Yeah, that's what I thought. But I feel like we have to have 2 do a certain trick. Like a certain trick to basically give us one of the numbers. Because we can't really have like a negative square root. That's why I thought of the square root. For like being an element of P2 at least. Unless I wrote the set notation incorrectly. But replace 1 by -1 in P2. I mean, it's like P2 is equal to the square root of -1. I mean, that'd be funny. I mean, when I think about it deeply, it kind of would work? I don't know. Yeah, sure. You can give a hint, Don. I wasn't sure if you were setting up for stuff on your end. That's why I didn't ask. It's like, that's an idea. It's like, just make it the negative square root of 1. But then, like, it would be like, but what's A? What's A in this instance? That's just me goofing. It's probably not that. Yeah, I was just fooling around. Let's see. The goal of the definitions is to give you positive real numbers. The question is asking you to break that. So I would think about some example that don't involve positive reals. And why don't they work? Do you know how algebraic cycles arise on a scheme? pull back and project the maps. I was watching a seminar. So, ooh, interesting. Just replace 1 by -1 inside of P2. What, like that? Is that what you meant, Sasha, or like was it like something totally different? So I'm just gonna reread what Don posted. The goal is, the definition is to give you the real positive numbers. The question is asking you to break that, so that I would think about some examples that don't involve positive reals and why they don't work. If you are struggling to go, if you're struggling, just go to algebra. Algebra doesn't punish your lack of background like unlike analysis. I mean, is that wise to do though? Because I thought real analysis, basically once you are able to master real analysis, you should be able to be good with like other proof-based math. I mean, that's why I'm kind of struggling with real analysis, because I thought you needed to know this as like the backbone to proof writing. I mean, you could take an intro to proof course, sure, but I thought this would basically open you up to like higher levels of math, such as topology and you know, maybe differential geometry or something. Oh, okay. So you type, I saw what you type. It basically says you thought so too, but then I'm guessing algebra, abstract algebra basically was like, nope, you don't really need those. And I'm like, okay. Well, I'm not gonna take it like, you know, at face value, you know, because like I probably should learn like some stuff like Cauchy's, Cauchy convergence and all that stuff. Yeah, this stuff is really good to know too. I mean, like, the thing about real analysis is that, like, yeah, you get to know more about the properties of the real numbers. And I get why, like, mostly, like, math majors have to take it. And I understand why it's so hard. I'm barely able to get, like, past chapter 1. I'm not even past chapter 1 because of these questions here. But of course, like, math majors, they have to learn how to struggle with these type of things. I mean, if I was like studying in school, I would be panicking right now because I would be like, oh my gosh, I don't understand any of this. Or it's like, I think I understand it, but then when I write it, it's like, nope, this is not how you write the proof. And you're like, oh, dang it, I feel so defeated. This is why I can understand why people had to take real analysis 3 times in order to like actually get their degree. Algebraic cycles is related to struggling is how you learn, but it is really frustrating. Yeah, I guess, yeah. This is probably the reason why Alice in Wonderland is written by a mathematician, just going down the rabbit hole into like very bizarre things and bizarre worlds. But yeah, if we have P2 equal to -1, then So then we basically have that basically -1 is an element of the field. A is not 0, so that fulfills that. It's not positive A, but it is negative A in this case, if like, you know, A was 1. But it's not both, so it does fulfill 2, I think. Now for, I mean, like if A is B, so if we had like -1 plus B, then technically that would not be in P, because P is supposed to be a -1. But would that work though? Did we actually break it? That's my question. Because if we have like B and we multiply it by -1, which is A in this case, then basically it will be negative B, which is not contained in P2. I mean, that's how I'm breaking it down, but I'm not sure if that's the right way to break it down, though. I mean, I'm lucky I have you guys with me to, like, you know, tell me when my thinking is off. Because I can't imagine being in the library by yourself and you're basically just, like, trying to figure this all out. And if you're trying to self-teach yourself, then that's the harder part. Because it's like, oh my gosh, like, I need to actually go to a professor to learn this. Oh no, I was just basically saying, like, the way I break it down is that if A, let's say if P2 is equal to -1, right? And like, when we think of if A is equal to -1, then basically it does fulfill the requirement of like A being in the field, and A is non-zero, and positive A is not in P or P2 in this case, but it is in negative like 1, or in this case, you know, negative A is in P2, but they're both not in like, you know, 1 and -1 are not in the field at the same, I mean, not in P2 at the same time. And if we basically take, like, say A is equal to -1, because we have A and B, then we would have like -1 plus B, which is technically not in P2. And then we would have like -1 times B, which is not in, which is negative B, which is not in P2. So I do feel like it kind of works, but I don't know if that is the correct way to go. I'm just, yeah, I agree. It fits to, for thinking about 1, you can take both, A and B to be negative. It might make it more clear. So yeah, so then that would be -2, and that's not in P2. There's no rule saying that A and B are distinct, right? As far as I know. Yeah, there isn't. So they could be the same number for all we know. But either way, it won't give us -1 back. Except because like if we multiply, if they're both -1, then basically we would have like -1 times 1, which gives us -1. Or I mean, because like that's the only way it would, because it has to be both addition and multiplication. So it kind of, I think it works, because it has to fulfill both addition and multiplication. So we can get -1 for the multiplication, but there's no way we're gonna get it -1 on addition unless like B was equal to 0. That's the only way I can see it. But if B is equal to 0, then that means it breaks, because then let's say if A is -1 and B is 0, right? Then we would have 0, and that's not in P2, so it breaks. So I feel like it kind of works. I mean, I guess that would count it as an example because I can't see any other way that makes it wrong. Like, I mean, that kind of does not discount it. So I think that might be it. Because that's the best way I can break it down. I'd say there's almost more there's more interesting answer to the question, but this would work as far as I know. Okay, cool. As long as one of you guys say that, then that is particularly fine, because whew, we went through a lot with this question. I didn't expect that we would be taking this long for this one question. And it's an example question, it's not a proof-based question. But I guess we learned a lot from this one. At least I did. You guys are probably just like already knew this, and it was like the answer is so obvious. It's right in front of you. Like, who'd have thought that basically letter B would basically be one single number? That's pretty interesting, though. I guess when in doubt, just think of one number that breaks the whole thing instead of one set. I guess that's basically how we'll think about it. Sure, Don. You can explain what you were thinking. Because actually, the way you broke it down made more sense, because it basically say, I wasn't thinking about breaking the positive numbers. I wasn't thinking about that. Because I was like, it doesn't really say that in the question. It's like, we want you to break the positive numbers. And I was like, oh, they want you to break the positive numbers. I didn't think about that. That's a pretty interesting idea. The answer I thought of is the negative real numbers. That's exactly it. I'll check the seminar a couple more. Oh, okay. I guess you guys are talking about something else. I mean, yeah, that doesn't seem like it's a wrong answer, because I guess any negative number would work. Because let's say if B was, if you pick like all the negative numbers and basically like you would get a negative and a negative, which fits P. But then when you multiply a negative with a negative number, then basically you won't get anything that's the negative numbers in P2. That actually works, yeah. I'm like really disappointed that I didn't think of that. So all the negative numbers work. Okay, so that's kind of good reference. I'll probably remember this question for not the rest of my life, but probably a good long time. Now that I think about it, it's all part of the process. Yeah, true. It's all part of the process. Well, at least we managed to finish this one question. I mean, you guys mostly helped me along the way, so. Oh, it's your birthday, Don? Yo, happy birthday. Wow. Dang, I didn't bring any cake. Oh, he says that every day? Oh, okay. I didn't know that was a thing. Well, thank you guys for joining me today. At least you guys in chat were helping me with this one question. But I guess one question done is better than none, right? Because there were streams where I didn't get any questions done, and that usually feels the most disheartening. But yeah, so for anyone that is watching this on Twitch, you know, like if you like math, physics, or just learning in general, or you just need like a productive stream to keep you working on your computer for whatever project you're doing, you know, drop me a follow. It really helps. And if you have an Amazon Prime sub, you know, if you want to use your Prime sub on a math channel, you know, it doesn't have to be mine, but it could be like any other channel on Twitch if you want to use it for there. But if you're watching this on YouTube, you know the typical ritual. If you like the video, you know, hit the like, comment, and subscribe. And, you know, it will motivate me to put more of these VODs up on YouTube to help you on your mathematical journey, physics journey, or, you know, your productive journey as you go along. So tomorrow, I don't know if we're going to continue on with proofs. Maybe I will do a little bit of reading on Cauchy sequences, because actually, Sasha, I want to ask you this question, because in the book that I'm using, where's the chapters? Here it is. They do go over a little bit of cardinality in between sequences. Do I need to know anything about that, or can I just leave it alone? Like, should I just go to sequences and just, like, try to read up on those more? Because I know we have to go over Cauchy sequences again. At least I do. I have to actually go over those. Oh, I can skip cardinality? Okay, yeah. Because I think it's interesting, because I did read a little bit about bijections, and I think that was really interesting, because I think it was the way they explained how certain infinities match, even though it couldn't, you wouldn't think of it. Like, say if you had the infinite sequence of, like, even numbers, and you pair it off with, like, the sequence of natural numbers, they pair off very nicely, and the infinity is about the same. I think, I don't know if I'm thinking of that right. It's a fun subject and useful. Oh, okay. So, yeah, so they have sequences, series. I think I have to read these 2 chapters. They have a little bit of topology, which I'm pretty excited about. I probably would love to read that. Continuity, that's definitely a must. This is definitely a must. This is definitely a must. Oh, interesting. I'm guessing the only chapter that's not a must is cardinality. It's a fun subject and sometimes useful. Okay, I'll probably would have to read that later. Cardinality. Okay, for the Twitch chat, the Discord's already there, but I will post my YouTube channel on the Twitch chat, so if you guys want to sub to my YouTube channel, you're more than happy to do so. In addition, we already have the Discord, so I will also put my gaming channel, my Uncle Talks channel there, where I play video games. So far I'm playing this game called Lost in Random, the Eternal Die. I'm basically mixing up words there. I've been playing that game on Twitch, and I'm loving the game, so if you guys want to check out my stuff there, you're more than happy to do so. And if you're watching this on YouTube, all the links will be in the description down below. Okay, guys, I think that will do it for today's stream. I will be back tomorrow, so in case I am not, you know, I will update you guys on the Discord. Paid 100 to be patron on your YouTube channel. Oh my gosh, you know, like, are you joking, or are you being serious? I'm guessing that's just a joke. I'm guessing that's a joke, because I want you to save your money. I want you to save your money if you need it for other stuff. But yeah, guys. I think, should we do a raid? Is there anyone doing math right now? Let's see if we can do a raid. Oh, Academy is streaming. We can basically raid him. Okay. I'm guessing you're joking, Des. Alright, so I'll give the raid command. And I'll copy that. And then I will do the raid for Academy of Useless Ideas. Alright, there we go. Alright, thank you for joining me today, guys. And always remember, everyone is precious. You guys are just as precious as everyone else. And I will see you guys on Academy's channel. So take care, guys. Bye-bye.